watching this video on streaming live, is we are going to continue on with the lesson 2 on unit 4 that we've already started yesterday. So just diving right into example number 1. This time we're going to do some combining of functions. The only difference compared to last class or last lesson was that this time it's going to be n being x plus 1. So we're given 2 of those functions. Letter A, state today. I'm going to do it on a separate sheet of paper just because I don't think we have enough room in here. So I got mine here. So example number 1. Combining functions. So this is found on page 7 of our booklet. So letter A, we are given f of x equals square root of x minus 2 and g of x is equal to x plus 1. So letter A, state the domain of both g of x and f of x, and g of x. So we're going to look for the domain or state the domain. Starting off with this one. Domain of f of x. Because this is a square root function, square root of x minus 2, this is greater than or equal to 0. So I'm just going to write that down so that we have all of that. This function is defined only when x minus 2 is already. We can't take the square root of a negative number. Okay, so let's figure that out. So what are the numbers that will be allowed? So that means x to be greater than or equal to 0. So bring that to the other side of the equation. So x is greater than, that is greater than or equal to positive 2. So the domain, that's a set notation way of writing the domain. Or if we want the interval notation, we can say to g of x. So function of g of x is x plus 1. So domain of g. Okay. So this one looks like, we know this already, this is a linear function. And because it's a linear function, the domain of that are all real numbers. So that one's real numbers. Okay, so we can write that down. Or we can say negative infinity to positive infinity. So this is the domain. X is an element of real numbers. Domain in a set notation. And then this is the domain, but the domain is in interval notation. Either one is perfectly fine. I just want to point out. So letter B. Reading letter B. Given that they're introducing this new function, their new function m of x, and they're saying that this new function is a combination of f of x and g of x added together. What we're going to do is we're going to write the explicit equation for m of x, then determine its domain. So let's just do that. Turning back to my scrap paper, not scrap paper, but my paper. So what did I say? M of x, right? M of, writing down the explicit function. So m of x, well, we know f of x. We know f of x is the square root of x minus 2. Okay? And we're going to add that to g of x. We know g of x is x plus 1. So now, here is the explicit form of the function f of x. So explicit, what did I use? For m of x. Using that information, we're supposed to write down what is the domain of m of x. What is the domain of m of x? Okay, so how do we figure that? Is a combination of two functions. We know it's a combination of f of x and g of x. So it's gonna, so f of x, we know the domain. The domain is from 2 to infinity. 2 to infinity. That's the domain. And the g of x, negative infinity to it together right there. The function is not defined, so we won't be able to add f of x and g of x. Valid for both functions, or defined for both functions, is from 2 to infinity. So you can see here, I'm just going to circle that, 2 to the infinity. So therefore, domain of m of x is going to be x greater than or equal to 2. That one is a set notation of the domain, or we can say negative and negative, oh, not negative to positive. Okay, so we've done letter A, we've done letter B. Now let's take a look at letter C. Letter C, I'm just going to flip it over. Let's read it together first. It says, given that P of x is equal to f of x times g of x, write an explicit equation function. The new function says P of x, but this P of x is equal to f of x of x. So what we're going to do is we're going to write down letter C. So the new function P of x is equal to f of x times g of x. Write an explicit equation. So P of x is equals to f of x. Okay, well, f of x, we know it's square root of times g of x. G of x is x plus 1. Okay, so we can write it like that. We can leave it like that. And looking at this one again, write the explicit equation. We did that. Then determine its domain. Okay, so looking at the domain of P of x, the domain of P of x, again, this f of x is only valid for x greater than or equal to 2. G of x is only valid for any real number. So if we were to combine those two, okay, if we were to combine those two and multiply those two functions, the domain is still set notation, or 2 to infinity. That's the interval notation. Okay, so that one's not bad. Now let's take a look at letter D. And it says optional. It says using graphing technology to graph M. Now it says here, using graphing technology. We're gonna try to see if we could graph that by hand, because I think we know how, right? Graph those two functions. So graphing M of X. Now, we could do it in two different ways. We could do it in two different ways. We can say S, f of X, and g of X. Okay. So with f of X there, that's square root of X minus 2. So we're going to pick some numbers. Okay. I'm just going to pick. Now we already know that the domain is 2 and higher than 2 and greater than 2. So I'm going to start with 2. 2, 3, 4, 5, 6, 7, 8. Okay. I'll go. Just stop at 8. Okay. Now, what about f of X? So f of 2. Okay. So how do we figure out f of 2? It's going to be square root of X minus 2. And then g of X. Okay. So let's give it a row is 0. So if it's 3, we're going to substitute 3 for X. So 3 minus 2 is 1, and square root of 1 is 1. Let's try is 1 point something. I know I can square root of 2. 1.4. Approximately 1.4. And 5. So if I'm going to substitute 5 there, so 5 minus 2, that's going to be 3. So that's going to be square root of 3. Square root of 3 is approximately 1.7. We're just going to round this off. And if X is 6 in here, then it's going to be 6 minus 2. It's going to be 4, and square root of 4 is, and then 7, it's going to be square root of 5. Square root 5 is 2.2, approximately 2.2. And if X is 8, it's going to be 8 minus 2, that's going to be 6, so square root of 6, 4. I think that should be enough. Okay, we should be able to see the shape of the graph from there. Now, what about this one? G of X. G of X is X plus 1. So we're going to kind of ignore this column here. We're going to use X. This column here, X and the G of X. So if X is 2, G of X is 3. If X is 3, G of X is 3. Okay. So we're pretty much using the same strategy as what we were doing before, but this time we actually know the function, the specific function. So in this particular column, this one will be M of X, which is equal to f of X plus G of X. M of X plus G of X. M of X equals f of X plus G of X. So what are we going to do? Well, we know that f of X is 0 and G of X is 3. So we add those two together. So this is going to be 3 Add these two together. F of x plus g of x is 5. 5. 1.4 plus 5, so that's going to be 6.4. This one would be 1.7 plus 6 is going to be 7.7. And then this is going to be 9. And then this is going to be 10. Last one would be 11.4. Okay. I think that should be enough for us. So what we can do is we can, if you have graph paper, go ahead and grab a graph paper. I'm going to do the same thing. Okay. So on my graph paper, or even just on my paper, what I could do, so I'm going to use these two columns for graphing. Use these for graphing y values. So let's go ahead and do that. So that's example number 1. This is the m of x equals to p of x. Oops. I meant f of x plus g of x. What values do I have again? From 2 to 8 on x and 3 and give more room. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x, and then on my y, got 1, 2. Okay, I'm just using a scale of 1 in here for my graph, so let's go ahead. Points 1 would be 2, 3, so 2, 3. 2, comma 3, so 2, 3. The next one is 3, 5, so 3, 5. And it says here 4, approximately 6.4. 4, 4, 6.4, so somewhere here. 5 is 7.7, so approximately there. And 6. Okay. Next one would be 7 and 10.2. 7, 10.2. And 8 is 11.4. So we're not expecting a straight line in here. It kind of goes this way. It's going to increase. So to show that it will increase forever that way, I'm going to write down and organize my thoughts in here first, and then I head back to the graph paper to graph this. So again, because this function is only defined for values 7 and 8. Okay. Now, f of x is going to be square root x plus 1. So all of these are pretty much the same thing as the one that we had above, but the only thing that's different is the last column. The last column will be p of x, because p of x is defined as f of x times g of x. So this is the only thing that's going to change. So let's go ahead and copy this down. So 0, 2.2, and 2.4. And then this one would be 3, 4, 5. I'm going to draw myself a line in here so that so this time here, p of x is equal to, so f of x is 0 times 3. So 0 times 3 is 0. 1 times 4 is 4. 1.4 times 5, so approximately 1.4 times 5 is 7. Approximately 7. It's not going to be exactly 7 because 1.4 technically is a non-terminating, non-repeating number. So this one here is approximately 7. Okay. And this one here is, we just rounded off to 1.7. So 1.7 times approximately 17.6. 1 is 2.4 times 9 is approximately 21.6. Okay. So what we're going to do is we're going to graph the first column and the last one. So these two are the things that we're going to graph. These two columns. Okay. So let's go ahead and do that and see what the graph looks like. So this is still example 1, but this time it's going to be p of x, where p of x is f of x times g of x. Okay. 2 to infinity, 2 to 8 on my table of values. And then here, we're going to get up to 21. So we'll see, as long as we can see the pattern. I'll use a scale of 1 again, and then so at all 0, 2 comma 0. Okay, so kind of put it back again here. So if x is 2, p of x is 0. And then the next one would be if x is 3, p of x is 4. If x is 4, 4 is about 7. And again, that one is an approximation. 5 is about 10.2. 5 is about 10.2. And then 6 is 14. So I see if I can fit 14 in here. So 14 point, 14. Okay. So that's kind of not looking like a straight line. I can't fit it in a straight line. And it hit all those points there. And as x increases, so does the value of p of x. So this is going to be p of x. P of x is equals to f of x times g of x. Okay. So, wow, that's example number 1 that we just finished. So let's go ahead and do example number 2. Let's do example number 2. This time, we're going to use f of x is equals to square root of negative x. And g of x is x plus 2 all squared. So this is a radical function. Okay, if we kind of think about how we learned last time, this one is a radical function, but because the b value is negative, so it's going to be reflected into the y-axis. So it's kind of looking like this, right? So just kind of a sketch of what that looks like. That's f of x equals to the square root of negative x. A quadratic function, and it's x plus 2 squared. So again, it looks like a x squared function, but then if we talk about this in terms of transformation from our last topic, this is a quadratic function, a parabola, g of x equals to x plus 2 squared. So now what we're going to do is letter A. I think I should be able to do that in here. Of f of x. We know that it's a square root function, and it's only defined when negative x is greater than or is, we can switch this to the other side to make it a positive, and then the 0 go to that side, or this one will be 0 anyway. So it's going to be 0 less than or equal to 0. So that means the domain, the x values are any values that are less than 0. So let's think about it less than 0. It's a negative defined value. So this is look over here. This is a graph. This is just a rough sketch of what that function is. Now, what about the domain of there, right? X plus 2 squared. Domain there is x is an element of real numbers, or we can say from negative infinity up to positive. And if we take a look at that one, yeah, this one really does look like the domain here is from negative infinity. As this goes this way, it's going to continually go up there, and it extends to the right side. Okay, so that one's not bad. What we're going to do is, it says here, given that, I think this is supposed to be q of x. Okay, let's put that in. Q of x. Because this is q of x. Given that q of x is equals to f of x divided by g of x. So now they're introducing this new function q of x, which is a combination of b. Okay, so there, q of x is equals to, what's the exact equation for that? It says f of x. Okay, well, what's x? F of x is square root of negative x divided by g of x. Well, what's g of x? X plus 2 squared. X plus 2 squared. So that undefined function, right? So what number will make the denominator 0? Zero. That's a non-permissible value. So x plus 2, okay, cannot equal to 0. So x equals to negative 2. Because if we put a negative 2 there, negative 2 plus 2 is non-permissible value. Okay, so having set a value for x, the numerator is also limited. It's limiting only for less than or equal to 0. Okay, less than or equal to 0. And also x cannot equal to negative 2 because that's a non-permissible value. So we know that the domain is going to be x less than or equal to 0, with an exception that except for x cannot be negative 2. And once we graph this, we're going to see what this is. And I think we've learned this before, and that is going to be the location of a vertical asymptote. That's the location of the vertical asymptote. So now let's go ahead and graph that thing and see what the graph looks like. Okay, so again, I'm going to grab another piece of paper. So this is my function. It's example number 2. F of x is equals to square root of negative x, and g of x is equals to x plus 2 squared. Okay, let's just do that. Now, we already know that this function is defined for values less than or equal to 0, and this one is for any value, so combine. So f of x equals in square root of negative x, and g of x is equals to x plus 2 squared. And then over here, that's my last column, I'll just go q of x is equals to f of x. I'll write down the explicit form, square root of negative x over So let's pick any values for x in here. X is going to be 0, 1, 2, 3, 4, 5, 6, and these are all negative. Okay, yeah, it has to be negative because the domain of that function is greater than or equal to 0. So let's go ahead and figure out the values of f of x. So if x is 0, so we're going to put 0 there. F of 0 is the square root of negative times 0 is 0. Okay. Now we're going to put negative 1. Square root of negative 1, so that's going to be a positive 1. Square root of negative times negative 2, that's going to be square root of 2, which is approximately 1.3. 1.4. And square root of 3 is going to give us 1.7. And these are approximate values, we know that. And then if x is negative 4, we're going to put negative times negative 4, which is positive 4. Square root of that would be 2, exactly 2. And then this is the square root of 5, which is 2.2. And square root of 6, so square root of 6 would be 2.4. Okay, so these ones are approximate values. Now let's take a look at this function over here. Let's take a look at this function over here. 0 in this function, so 0 plus 2 squared, that's going to be 2. 2 squared is going to be 4. 1, negative 1 plus 2, it's going to be 1. 1 squared is 1. If I put negative 2, so it's going to be negative 2 plus 2 is 0. 0 squared is 0. Negative 3, that's going to give us negative 3 plus 2, so it's going to be negative 1. Negative 1 squared, negative 2 squared is positive 4. If I put negative 5, so it's going to be 3. Negative 3 squared is 9. And then last but not the least, if it's negative 6 plus 2, that's going to give us negative 4. Negative 4 squared is going to be 16. Okay, I'm going to draw a line in here so I don't, because I'm just plain white paper in here. Okay, so I can see which lines go with what. Divided by the g of x, which is this column over here. So we're going to take this divided by that. Okay, we could do that. So 0 divided by 4, that's 0. 1 divided by 1, 1.4 divided by 0. Okay, now we're going to get into dividing it by 0. This is where it's undefined. Undefined. Okay, do my math there. 19.8. Back up my bus. Okay, divided by 4 is 0.5. And then 2.9 is about 0.2444. And then divided by 16, that's going to get into, okay, as you can see, as the more I keep going with this one here, this is going to get bigger, but this is going to be bigger much faster. So there's going to be two asymptotes in here. Okay, so let's go ahead and graph these 2 points, these points, not 2 points, these points. So we're going to take this column in here and that column right there. So these two. Again, if you have graph paper, go ahead and grab a graph paper. If you don't have a graph paper, you can still do this even without a graph paper. Okay. So this is my graph paper here. Take a look at example number 2. Q of x. I'll just do half graph paper. Okay, so I'm looking at my values here. My x values are just going to be from 0 to negative values, and then my q of x will be right here. So 1, negative 1, negative 2, negative 3, 1, 2. Okay. Now let's see if we can graph the first point. The first point is 0 right there. And then the next one, I'm just going to bring this back in here. It says here negative 2 undefined. Well, that asymptote. This is a non-permissible value, so this is our asymptote. Equals to negative 2. So what's happening in here is that as I move towards the asymptote, this is going to get larger this way. It's going to get larger that way. Okay. Now let's continue on with this one in here. The next one would be negative 3, 1.7. So negative 3, 1.7. So approximately there. Negative 4 is 0.5. 5 is 0.24. It gets smaller. And 0.6 would be even smaller. So that kind of looks like it's going this way. This is the other asymptote, y equals to 0. And why is that y equals to 0? Because the degree of the denominator is way bigger than the degree of the numerator. So if we divide it, it's going to approach to y equals to 0 for that one. Okay, so this is the horizontal asymptote. Okay, so in that case, we've graphed the f of x equals to negative x, square root of negative x, divided by the g of x, which is x plus 2 squared. Okay, so what have we? Okay. So we've done example 2, state the domain and range. We've done the writing the explicit equation and then determining its domain. And then the optional, which is graphing. It says here, using graphing technology. Yeah, you may use, because you know the exact equation, certainly you can use the Desmos on what we have. Okay, so that's great. Oh, and it says here, use a graph to estimate the range of function. Now, the range of the function, so we already figured out the domain. The domain is less than or equal to, we're going to talk about the range. The range is from 0 to infinity. 0 to infinity. Okay, not including 0, because the 0 is our horizontal asymptote. So example number 3 and number 4 should be not so bad. It says here, consider m of x, which is 2x squared plus 3x minus 7. Write explicit equations for 3 functions, f of x, g of x, and n of x, so that m of x could be the sum of these 3 individual functions. So this one here, many possibilities. So we'll take a look at letter A. It says here, we want m of x to be the sum of f of x plus g of x plus n of x. So can we think of 3 functions that when we add together will get us x equals to 3x, and the n of x is equals to negative 7. Okay, but this one here, many possible solution. Okay, so this is just one example. So if I put f of x, which is there, 2x squared plus 3x, that's your g of x, and then n of x minus, I'm going to put minus, oh no, plus negative 7. Yeah, because this is a plus n of x, so plus negative 7. Okay. Now let's take a look at this one here. Letter B. Write an explicit equations for 2 functions, f of x and g of x, so that m of x is equals to f of x minus g of x. Okay. Now, we already know that m of x is 2x squared plus 3x minus 7. So what we're going to do is we're going to look for 2 functions that when we subtract them together, we're going to end up with that. So what could that be? So we know that m of x is going to be 2x squared plus 3x minus 7. What would be our f of x minus g of x? That will give us that one. So again, many possible solutions in here. So we can say that, I'll just do an easy one here. F of x would be 2x squared plus 3x. And then I can say that g of x to positive 7. So if I put those in here, I can say 2x squared plus 3x. So that's my f of x, right? If I go g of x is minus positive 7, it would, if we clean it up, then it will get us the 2x squared plus 3x minus 7. But in this particular case, there are many possible solutions for that one. And we could be as creative as part. It says here, consider the functions p of x is equals to x squared minus 2x minus 15. Write explicit equations for two functions where f of x and g of x, so that p of x is the product of those two functions. So this one over here, letter A, we know that the p of x is equals to f of x times g of x. So p of x is two functions that when I multiply these together will equal that. Well, this polynomial function could be written like this: x minus 5, x plus 3. So I can say that one's not bad. And then we've reached the final example. Q of x is equals to x plus 3. Okay, given that q of x is x plus 3, write explicit equations for two functions so that f of x and g of x, so that the q of x is equal to f of x divided by g of x. So q of x equals to f of x divided by g of x. So q of x, we know that it's going to be x plus 3. So we can say that f of x be over x plus 4. Okay, so that would cancel that one, and we're left with the x plus 3. So therefore, x is equals to x plus 3 times x plus 4. And then the g of x is equals to just the x plus 4. Okay, wow. We've finished this all in one sitting, which is great. And I hope that we can work on some of these questions for the second half of our class. And of course, at this particular time, we are learning from a remote place. We can always pause, come back on page 278, starting on question number 3 to 11. It says here, do not do 5B and the multiple choice questions 1 and 2. I want to let you know that I will have my email open and ready, and you could certainly send me a message if you have any questions on any of the topic that we've done so far, or any of the questions that you've encountered or issues that you've encountered with the questions. Send me an email, and I will look forward to talking with you sometime again. And take care for now.